Welcome students, welcome to Helm of Science, and this is your physics class. And today we will be discussing about the chapter this simple harmonic motion. And simple harmonic motion is one of the important chapter in learning the physics and universe. And we will discuss about the simplest case of harmonic motion or oscillation or vibration. We will learn the difference between SHM, that is harmonic motion, oscillation, vibration, etc. So this will be very interesting class for your knowledge of physics. So stay tuned with us and enjoy the physics. When we are starting our study about the simple harmonic motion, the term I have written in bold. There is three words from English language, that is, one is simple, another is harmonic, and there is motion. So we have to know the three different terms and the three different logic in this motion, but it is simple. So first, motion, I have already told, or I have a video in this channel about the motion in a straight line. That is, motion is the movement of particle, movement of any body is motion. And there is another word, harmonic. So what is harmonic and why it is called the simple harmonic? Simple harmonic motion, because it is simple because of we can derive any complex or any double pendulum structure or any complicated motion in this nature using two or multiple number of simple harmonic motion. And harmonic is which the motion which repeats in some period of time, that is called harmonic. So let's start with the part harmonic. So the term harmonic depicts another term, that is harmony. So the motion which have a harmony or a special kind of rhythm, that is simple harmonic motion. So in starting of the harmony or harmonic, what is harmonic in this motion? So let's start with the topic, what is periodic motion? If a motion is completed or repeats within a period of interval of time, that is the periodic motion. So a motion which repeats in a period of time. Period means a particular time interval or a time interval. That is a periodic motion. So let's start with the example or have some example. Examples are everywhere in nature. That is the orbiting of planets around the sun and its own axis. If there is 24 hours a day, we can assume 24 hours is day and 12 hours is day and 12 hours is night. So after every 12 hours there is day, and after every 12 hours there is night. So it is after the same time the motion is repeatedly occurring, so it is a periodic motion. In summer you can observe a blade of fans. That is also repeating in some particular time. If it is moving like this, number 1, number 2, number 3 blade, so after some time this will travel and will meet again at this path, at this position. So this is a period of time. After a period of time, the motion is repeating, or its reach is initial position. So it is a periodic motion. Okay. And there is another example which I can give is clock, arms of clock. Arms of a clock, suppose this is 3, this is 3 o'clock, and after 12 hours this will be again 3 o'clock. This is AM, this is PM, and after 12 hours this will repeat this formation. So after every 12 hours the minute arm and the hour arm creates the same formation. So it's repeating after some time, some period of time, some particular interval of time. So this is a periodic motion. So what can we conclude from this is the time interval is same. The time interval is same. Now if I say that there is a field like this and a runner A is running around this field. Okay, so after each 10 minutes the runner A is reaching the point O. Okay, so after 10 minutes if the runner A is orbiting this ground and once again reach to the point O, this is a periodic motion. But suppose if the runner have a pet dog D and it runs here and there like this in the open field, and sometimes after it reaches O and again it moves like this and then it reaches again at O, but the time interval between two successive reaching at O point, at first time it may be 7 minutes, second time it could be 8 minutes, and again it could run here and again create a round shape and reach O in just 1 minute. So the dog is also reaching reaching the point O, but it is not in a same time interval. So this is not periodic, but this is periodic. This is the difference between the periodic motion and aperiodic motion. And there are many more examples in the universe or in daily life, which describes a periodic motion. There is also example like wheel of a car, wheel of a cycle must be uniform velocity. This is running wheel, uniform velocity. Now we will now discuss about another topic, that is a motion of a pendulum. We will try to draw a pendulum here. A pendulum particularly have two objects. One, there is a string of some finite length, suppose L, and there is a metallic or non-metallic heavy object of mass M. This is a bob, and it's given a little force here, so it will start oscillating like this. Okay, this is a pendulum, and this angle of maximum deviation is theta, and this is equal both. And if a pendulum creates a full round like this, this is a circle, this forms a circle. But if we consider this angle of deviation theta less than 4 degree, then this displacement could be taken as a straight line. Okay, so in this case we will consider a bob or metallic bob is moving to and forth in a straight line like this. Okay, like this, in a straight line, not like this. If theta is less than 4 degree, this will reduce our labor in understanding this pendulum problem. In this pendulum problem, one is the most interesting thing is that this bob is moving to and forth in a same line. The line is same. This is going this along this line and returning in this line and along this line. So the path is same. Same path. But in the periodic motion, now we will learn or start discussing about some important terms of oscillation. In this case, we will always consider the simplest harmonic motion or pendulum. This pendulum can save your physics. So learn it properly. Okay. So our first term is complete oscillation. So what is a complete oscillation? When we are giving a little force in this static pendulum like this, the pendulum will start vibrating or start oscillating like this way, in this way, okay, in this way, to and fro this way. So at some time, let's denote this position. This is 1, this is 2, and this is 3. 1, 2, 3. So this is our first position. The pendulum will go towards like this, and 2 from 1 again, and from this, and again like this. So when the bob of the pendulum is returned to the same point in the path, it will take some time. And when it returns to the same point, this is the complete oscillation. So when suppose the pendulum will start moving from 1, again it will reach 2, after 2 it will reach 1 again, and after 1 it will reach 3, after 3 it will reach 1, after 1 it will reach 2 again. So from 2 to this 2, this is the total complete oscillation, or you can say from this one to this one, this is the complete oscillation. You can say this one to this one will be the complete. No, this is not complete, because the half of the motion is completed here and the rest is yet to be completed. So from this one to this one, it is a complete oscillation, and or in this 2 to this one, this 2 to this 2, the position is the complete oscillation. Or it could be it is returning 3, 1, 2, again 1, again 3. So from this 3 to this 3, it is a complete oscillation. So when it is like going like this, returning this and this is our complete oscillation. Okay. Our next term to be learned carefully is number 2, time period. So time period is, as I have mentioned earlier, that the bob will take some time to complete a complete oscillation. So time taken to complete, time taken for a complete oscillation is time period. This is the time period, and the unit is second always, and it is denoted by capital T. So this is the time taken for a complete oscillation is the time period. So from this 2 to again 2, the time taken is time period. Okay, this is t. So t second. Now our next important term to be understand is number 3, and it is frequency. And you have to learn this term frequency very carefully, as frequency will apply. The term frequency comes very often in physics. So what is frequency? In the previous term, it was our time period t. That is the total time of a total time to complete a complete oscillation. So it could be experiment. It is an experimental value, and it could be any value like 3 second or 22 second, depending on the length of the pendulum and the force, or depending on the length of the pendulum particularly. And it could be 2.3 second, 1 second, or 9 second. A lot of values, anything could be this. So our frequency is complete oscillation in a unit time. In a unit time, suppose 1 second. In 1 second, how many complete oscillation is completed by the pendulum is the frequency. So number of complete oscillation by time. Suppose the pendulum is taking 3 seconds to take a complete oscillation, or in experiment, suppose you have recorded a time length that the pendulum is taking 20 seconds to complete 10 complete oscillation. So the frequency is 20 second 10 complete oscillation. So the frequency will be 10 by 20 equal to 1 by 2, and the unit is hertz. Number of complete oscillation is known as the frequency, and as the frequency per time, so its unit will be 1 by second, or second inverse. And in the name of the scientist Hertz, the unit is also known as hertz. Hz, we write it Hz. And we denote frequency as small n is 1 by time period. So if the time period is t, that is for a complete oscillation it takes t time. It takes t time for one complete oscillation. So in one time, unit time, it will take 1 by t complete oscillation. So this is the number of complete oscillations. Number of complete oscillation in a unit time is known as the frequency, and this is n hertz. Okay. And our next term is, it is also an important term, which is amplitude. Amplitude or amplitude. Suppose this pendulum bob is moving from this to this and again from this to this, and this is O position, this is our position B, and this is C. So initially the bob was at O position, and after giving a little force, the bob displaced a maximum distance OC, or from this position the bob displaced the maximum is OB. So the distance displaced from the initial or rest or equilibrium position is amplitude. Here OB, the initial or rest position was O. This is our rest position, and it displaced to C or displaced to B. So OB will equal to OC, and this is the amplitude. And this is our distance, so its unit will be meter in SI and centimeter in CGS. As I mentioned earlier, that is oscillation and vibration. Vibration is a fast process, and oscillation is a slow process. Like a pendulum or a string or a stretch string, or in case of the stretch string, it is vibration. Stretch string is vibration. It oscillates very fast, and slow it is pendulum. Okay, I gave here are two examples like this. So we can conclude at the end that harmonic motion is a motion which has a harmony or a rhythm, that a motion which repeats after some interval, after some time of interval, after a period of time. in a particular period of time. So that is a harmonic motion, and our chapter is simple harmonic motion. Why it is a simple harmonic motion? But because this is the simplest case of harmonic motion. That is why it is called the simple harmonic motion, SHM. I can give you some example like this. Suppose you have a pendulum and you have another pendulum. This is absolutely okay because you have two different pendulums, and by knowing the simple harmonic motion, the equations of simple harmonic motion, we can describe, or we can evaluate, we can calculate every kind of complex harmonic motion from this. Adding two or more simple harmonic motion could leads us to a complex harmonic motion. I am giving you a little idea. If here is a pendulum and there is another pendulum stuck here, so this vibrates. This will vibrate like this. Upper pendulum, when going here, the lower is going like this, and again when the upper pendulum is like this, the lower will be like this. So here is two pendulum, number 1 and number 2. So knowing the SHM simple case will leads us this two problem. You can, after knowing this, you can attach 3, 4 or multiple number of pendulum here. So this is very interesting chapter, and keep learning this chapter. And this was the idea of periodic. This class was about the idea of periodic motion and the harmonic motion, and this is these terms will leads to a better or clear idea of harmonic motion. In the next class, I will discuss the equation of a simple harmonic motion and the examples or some problem on simple harmonic motion. Thank you so much. Please subscribe our channel and press the bell icon, as you will notified when a new video is uploaded here. And you can enjoy your full science stream from class 9 to class 12. All science subjects are taught here. So please subscribe and like our channel, share with your friends. Thank you.